Test batch 1. All right. This is the video that should go along with the notes. So if you're not looking at the notes, this might not make sense. But the assumption is you should have there's a link for the notes that you should be able to get. We're going to go through the examples for each. I'll put the clips together as a video and hopefully put it on the right page. So on example 1, they're asking us ultimately, what's the savings for 25 light bulbs? Well, we have to look through all the words, look for the essential details. They tell us that the LED bulb costs $1.32 per year to run, and the incandescent bulb is $6.09 per year to run. So if they're asking us the savings for 25 light bulbs, first is, what's the savings for one light bulb? So the difference for one light bulb, difference is subtract, right? So if we look at the prices of these two, price per year, $6.09, take away $1.32, leaves us with $4.77. That's the difference for one light bulb per year. So the question is asking us for, what if you're replacing 25 light bulbs? So you'd take that difference, whatever the difference is between the cost, times it by how many light bulbs. In this case, we're multiplying by 25 light bulbs. We end up with $119.25. It's a pretty nice savings per year for replacing light bulbs. Check it out. Hopefully this is good. If I'm in it or not, we'll see in a second. Figuring this thing out, I'll get better. Just to warm up, for example 2, they want us to read the meters. If you look around your house, these meters are here. This is what they really use. However many dials there are in a row, that's the digits. So for example, if there was 3 dials, the smaller of the two numbers that the arrow is between, the smaller is the answer, except between 0 and 9. Look on your notes. So 0 or 1, which is smaller? 0. 3 or 4, which one's smaller? 3. Between 4 and 5, which one's smaller? 4. So 0, 3, 4 would be simply the number 34. On example 2, from your notes, they give you a dial that has 5 circles in it. These 5 circles right here, we end up with 2, 3, 4, 5, 4. Remember the smaller number of each one. Since it's 5 digits, put the 5 digits in order. 23,454 units would be represented by those dials. So the second part of that question, they ask, all right, well, if they told us it was 85 cents per unit, what would the cost of this meter's bill stand for? So you take the number of units, multiply by the cost per unit, 85 cents in this case, $19,935.90. Example 2, we'll get better. All right, the last one went pretty good, so hopefully this one goes all right as well. We're on to example 3. Once again, from the notes, you got to look at example 3. Example 3 is talking about using an electric mixer, how much it would cost to actually run that thing for a certain amount of time. So what we know from the problem is they told us that it uses 125 watts. They used it for 90 minutes, and the cost is 10 cents per kilowatt hour. We're going to have to figure out kilowatt hour. So first things first, they told us 90 minutes, but this needs how many hours? So to first change 90 minutes into hours, 90 minutes divided by 60 minutes, because there's 60 minutes in an hour, gives us 1.5 hours. We're going to use that to find the watt hours. Now, it's not kilowatt hours, but just watts per hour, basically. So we're timesing. Watt hours, watts times hours. Watts times hours used. So the watts from up here is 125 watts times 1.5, which is the hours used. We multiply that out and we get 187.50. So that's the watt hours, but we need kilowatt hours. Kilowatt hours, there's 1,000 watts in a kilowatt. So to find the kilowatt hours, we'd have to take the watt hours divided by 1,000. So we take our 187.50 and divide it by 1,000, and that gives us 0.1875, decimal 3 places over. So that 0.1875, that's now kilowatt hours. So ultimately they asked us, what's the price per kilowatt hour? So we take the cost, which is 10 cents, times how many kilowatt hours did they use? 0.1875, which is 0.01875. Now, ultimately, we're talking about money. So if we're talking about money, remember, this has changed. $0 and something cents. So if you're talking change, you're talking like 1.875 or about 1.9 cents. This one might be a little off looking, but the math is good and hopefully the audio helps. All right, we're going to try this again. I'm trying to get this thing centered. It'll get better as we go. I'll figure out a better system. But let's get on to example 4. In example 4, they're talking about buying a new water heater that's going to save them money, and they want to know how long will it take before it pays off for itself. So a couple things. First of all, the cost of using the old one was $455 per year. The new one, they said, is going to save you 31%. So if you take 31% of 455, that's how much savings you'll get in 1 year. So remember, 31%, we got to remember our decimal thing. 31% is 0.31, 2 decimals. Of 455, remember from our word problems, of is multiply. So 31% of 455, we're going to multiply. So $141.05 is the savings per year, just between the old and the new. So you bought this new heater. The new heater, the purchase was $1,240. So basically, if you're saving $141 a year, how many years makes up that much money? We're going to divide them. The cost, $1,240, divided by how much you're saving each year, $141.05, comes out to be this decimal, about 8.8. But if you're saying 8.8 years, about 9 years, and somewhere around there. And once again, we show our work. That's going to be great for full credit. So let me just make sure and move it around just to make sure you can see it off. You can pause, but once again, hopefully the audio makes sense. That's 11-1.